Imagine standing on the rust-colored surface of Mars, your boots sinking into dust that hasn't been disturbed in millions of years. The sky above you isn't blue, it's a hazy pink, stretching out over rock formations that look like they were carved by some unseen hand. This is a world that feels both alien and strangely familiar, a place where every crater and canyon holds secrets we're only just beginning to uncover. Over the decades, our robotic explorers, the rovers and orbiters sent to study this mysterious planet, have beamed back images and data that defy explanation. From bizarre geological formations to objects that seem almost out of place, Mars has a way of keeping scientists and the rest of us guessing. Today, we're diving into 30 of the strangest, most jaw-dropping discoveries ever made on the Red Planet. Some of these findings might make you question what you thought you knew about Mars, like the towering structures that look eerily artificial, or the shiny metallic objects spotted lying in the dust as if they were dropped there. Others might send a chill down your spine, like the ghostly faces and shadowy figures that seem to peer back at us from the rocks. And then there are the phenomena that even NASA can't fully explain. The mysterious lights, the underground caverns, the patches of terrain that change shape when no one's watching. This isn't just a list of oddities, it's a journey into the unknown, a chance to explore the edges of what science can tell us about our planetary neighbor. Every one of these discoveries raises bigger questions. Could there have been life on Mars? Are we seeing the remnants of some ancient civilization, or just the tricks of an alien landscape playing with our minds? As we count down these 30 strange finds, keep your eyes open, because by the end, you might start seeing Mars in a whole new light. Buckle up, because this ride is going to get weird. The first strange discovery on our list is perhaps the most famous and controversial of them all. Back in 1976, NASA, a Viking 1 orbiter, snapped a photo of the Cydonia region on Mars, revealing what looked like a massive human face staring up from the surface. Towering over a mile wide with what appeared to be symmetrical eyes, a nose, and even a mouth, this eerie formation sent shockwaves through the public imagination. Was it a monument left behind by an ancient civilization, a message carved into the planet itself? The image became fuel for endless conspiracy theories, with some insisting it was proof of intelligent life on Mars, while others believed it was being covered up by governments. But science has a way of unraveling mysteries. Decades later, new missions like Mars Global Surveyor and Mars Reconnaissance Orbiter captured high-resolution images of the same region, revealing something far less dramatic. The so-called face on Mars was nothing more than a trick of light and shadow on a heavily eroded mesa, its seemingly perfect features dissolving into the jagged, wind-scarred rock of a natural formation. The angle of the sun during Viking 1's flyby had played a clever optical illusion, making a random geologic structure look eerily deliberate. Yet even after NASA debunked it, the legend persisted. Books, documentaries, and radio shows kept spinning wild theories. Some claimed the newer images were faked, others insisted the real face had been digitally erased. The fascination with the face on Mars speaks to something deeper. Our urge to find meaning in the unknown, to see familiar shapes in alien landscapes. It's the same instinct that makes us spot animals in clouds or faces in tree bark. Only here it played out on an interplanetary scale. What's fascinating is how this one image shaped public perception of Mars for decades. Before rovers and high-definition cameras, the Red Planet was a blank canvas for our imagination, and the face became a symbol of all the unanswered questions lurking in its dust. Even today, as we uncover clearer evidence of Mars' geological history, that grainy Viking photo remains a cultural landmark, a reminder of how easily the line between science fiction and science fact can blur in the vast, silent deserts of another world. Moving from optical illusions to tangible mysteries, let's talk about one of Mars' most peculiar geological features: tiny, spherical rocks scattered across the surface like nature's own marbles. When NASA Opportunity rover rolled across the plains of Meridiani Planum in 2004, its cameras spotted countless small, round objects littering the ground. These strange formations, no larger than BB pellets, stood out against the rusty soil with their smooth, almost polished appearance. Scientists quickly dubbed them blueberries, not because of their color, they're actually a deep gray, but because of their uncanny resemblance to the fruit in size and shape. But these weren't just random curiosities. Analysis revealed the blueberries were made of hematite, an iron-rich mineral that often forms in the presence of liquid water. On Earth, hematite concretions like these take shape when mineral-laden water flows through porous rock, gradually depositing layers of iron oxide around a central nucleus, like a pearl forming in an oyster. The discovery sent a jolt through the scientific community, because if Mars blueberries formed the same way, it meant water once soaked these now parched plains. What's even more tantalizing is the scale of this phenomenon. Opportunity didn't just find a handful of these spheres, they were everywhere, embedded in outcrops and loose on the surface, some even clustered together like grapes. Their uniform shape suggested a consistent, widespread process, hinting at a time when groundwater might have percolated through the Martian subsurface for thousands or even millions of years. Of course, not all scientists agree on the exact formation story. Some argue acidic water or volcanic steam could have played a role, while others propose that wind erosion sculpted pre-existing mineral nodules into these near-perfect spheres. But whether shaped by gentle water or harsh winds, the blueberries remain one of the most compelling pieces of evidence that Mars wasn't always the dry wasteland we see today. They're tiny time capsules whispering secrets about a wetter, potentially habitable past one where rivers might have flowed and lakes could have shimmered under a pale pink sky. And here's the kicker: similar hematite concretions exist on Earth, from the deserts of Utah to the outback of Australia. When we find familiar things in alien landscapes, it blurs the line between otherworldly and recognizable. The blueberries don't just rewrite Mars' history, they make the red planet feel a little less distant, a little more like a place where the rules of geology, and maybe even biology, once played out in ways we're only beginning to understand. Now let's talk about one of the most baffling moments in Mars exploration history, a rock that literally appeared out of thin air. In late 2013, NASA Opportunity rover was trundling across the Martian plains when mission controllers noticed something bizarre. A photo taken on Martian Day 3528 showed nothing unusual, just the usual dust and scattered rocks. But 12 days later, another image revealed a startling new feature: a pale, almost white rock roughly the size of a jelly donut perched in a spot that had been empty before. Scientists nicknamed it Pinnacle Island, though the public quickly dubbed it the Jelly Donut Rock, thanks to its round shape and light-colored center surrounded by darker edges. The internet erupted with wild theories. Had a meteorite landed nearby, kicking up debris? Could it be some kind of fungal growth? Or, as some fringe theories suggested, was this evidence of hidden activity on Mars, like a rover malfunction or even something more unnatural? NASA official explanation was far simpler but no less fascinating. After careful analysis, they concluded that the rover's wheels had likely flicked the rock out of the ground as it maneuvered. The rock's underside, which had been buried, was brighter because it hadn't been exposed to Mars' harsh, oxidizing atmosphere. Essentially, Opportunity had flipped over a Martian pancake, revealing a side untouched by wind or dust for possibly millions of years. But here's where things get even more interesting. The rock's composition didn't match typical Martian geology. It had unusually high levels of sulfur and magnesium elements that hinted at a watery past. Some researchers speculated it might be a fragment from an ancient impact, while others wondered if it was a piece of bedrock shattered and ejected by the rover's movement. The real mystery wasn't just how the rock got there, but what its odd chemistry said about the history of that patch of Mars. What makes the jelly donut rock so compelling is how it underscores the unpredictability of Mars exploration. Even after a decade on the surface, opportunity could still surprise us, revealing secrets hidden just beneath our wheels. And while the appearing rock might not be proof of aliens, it's a reminder that Mars still has countless stories left to tell, buried in its dust or tucked just out of sight, waiting for the right moment to roll into the light. If you thought Mars had shown us all its oddities, wait until you see this vast patch of terrain so bizarre, it looks like something straight out of a fantasy novel. In the equatorial region of Mars, NASA Mars Reconnaissance Orbiter captured images of a landscape covered in what can only be described as dragon scales. Stretching across the cracked, rusty surface are thousands of overlapping, plate-like formations, each one ridged and textured like the armored hide of some mythical beast. The effect is so striking that even seasoned scientists did a double take when the images first came down. So what are these scaly structures? The leading theories swing between two dramatic possibilities: ancient mud cracks or frozen lava flows. On one hand, the texture could be the remnants of a long-lost lake bed, where wet sediment dried and fractured under a disappearing sun, leaving behind a mosaic of hardened tiles. On Earth, similar patterns form in dried-up riverbeds or playas, but Mars' version is on an entirely different scale, with individual plates spanning several feet across. The cracks between them run deep, suggesting whatever process created them was far more extreme than anything we've seen on our own planet. Then there's the volcanic angle. Some researchers argue these scales might be the work of slow, viscous lava flows that cooled and cracked as they inched across the surface. On Earth, similar formations appear in places like Hawaii, where thick lava skin wrinkles and breaks as it moves. But Mars' scales are larger, more uniform, and eerily geometric, almost as if nature decided to arrange them with deliberate precision. What makes this even more puzzling is the sheer complexity of the terrain. In some areas, the scales overlap like shingles on a roof, while in others they fan out in radial patterns, as if some immense force pushed them outward from a central point. There are even spots where the plates seem to curl upward at the edges, like brittle parchment caught in a breeze. The more you zoom in, the stranger it gets: tiny ridges within ridges, fractures that branch like lightning, and mineral deposits that gleam in the sunlight as if dusted with frost. Despite years of study, no single explanation fully accounts for every detail. Could it be a mix of both mud and lava, with water and fire shaping the landscape in tandem? Or is there some entirely unknown process at work, one that doesn't have an earthly counterpart? The dragon scales of Mars remain one of the planet's most visually stunning mysteries, a reminder that even with all our rovers and orbiters, this world still holds puzzles that defy easy answers. And maybe that's the most thrilling part, the idea that somewhere in those scaly, sun-baked plains, there's a story waiting to be decoded, one that could rewrite our understanding of how planets evolve. One of the most delightfully absurd moments in Mars exploration happened when the internet collectively decided a rock was in fact a rodent. Back in 2012, NASA Curiosity rover snapped a series of images in Gale Crater, and eagle-eyed viewers quickly zeroed in on one particular silhouette, a small, shadowy shape perched on a rock, complete with what looked like ears, a snout, and even tiny paws. The Mars rat, as it was instantly dubbed, became an overnight sensation, with forums and tabloids buzzing about the possibility of a furry Martian resident caught on camera. Of course, scientists were quick to explain this as a classic case of pareidolia, the human brain's habit of seeing familiar shapes in random patterns. We do it with clouds, toast, and mountain ranges, so why wouldn't we do it with rocks on Mars? The rat was just a wind-sculpted stone, likely basalt or another volcanic rock, with shadows and angles conspiring to create the illusion of a creature mid-scurry. But what's fascinating isn't the debunking, it's why this particular rock struck such a chord. The Mars rat tapped into something deeper, our longing for Mars to feel alive. A rodent isn't just a random shape, it's something warm, scrappy, and relatable. If a rat could survive on Mars, then maybe humans could too. It's the same impulse that makes us thrilled by potential microbial fossils or alien bones in rover photos. Each one feels like a clue in the ultimate cosmic detective story. Even more telling is how these moments persist despite overwhelming evidence to the contrary. When NASA clarified the rat's true nature, some dismissed it as a cover-up, while others doubled down, pointing to nearby rocks they claimed looked like squirrel burrows or lizard tails. The Mars rat wasn't just a rock, it became a Rorschach test for our hopes and fears about extraterrestrial life. And let's be honest, Mars is the perfect canvas for this kind of speculation. Its barren landscapes are just familiar enough to tease our imagination, but just alien enough to keep us guessing. Every jagged outcrop or odd shadow becomes a potential signpost, a whisper that maybe, just maybe, we're not alone in the universe. The Mars rat may have been a trick of the light, but the excitement it sparked, that was very, very real. Among the countless rocks and dust devils of Mars, Curiosity rover once spotted something that made even seasoned NASA scientists pause, a small, gleaming object that looked completely out of place. Nestled in the ruddy dirt of Gale Crater was a sliver of material so bright and reflective, it seemed to wink at the camera like a piece of discarded metal. The internet predictably exploded. Was this a bolt from an ancient spacecraft, a fragment of some long-lost Martian technology? The theories spiraled into sci-fi territory almost instantly. But the truth was far simpler and, ironically, just as fascinating. After careful analysis, the mystery object turned out to be a tiny flake of debris from Curiosity itself. Likely a shred of insulation or a fleck of material shaken loose during the rover's harrowing landing, the fragment had been resting on the surface, polished to a shine by Martian winds. It wasn't alien, it was human-made, a tiny piece of Earth that had traveled millions of miles only to end up as cosmic litter on another world. What's remarkable isn't just the explanation, but how these moments reveal our instinct to anthropomorphize Mars. A shiny spot in the dirt becomes a beacon of possibility, a clue that maybe, just maybe, we're not the first to leave a mark there. This psychological quirk has a name: the Mars effect. The planet's stark, otherworldly landscapes seem almost designed to play tricks on us, turning mundane geology into Rorschach tests for our wildest hopes about extraterrestrial life. Even more telling is how these discoveries expose the gap between public imagination and scientific reality. When Curiosity's team shared the metallic fleck's true origin, some dismissed it as a cover-up, while others doubled down, insisting NASA was hiding the real story. The object became a magnet for conspiracy theories, proof that our fascination with Mars isn't just about science, it's about storytelling. Every strange rock or odd shadow becomes a potential plot twist in humanity's greatest mystery: are we alone? But here's the twist: scientists love to point out Mars does have metal, just not the kind conspiracy theorists want. Meteorites rich in iron and nickel litter the surface, and the planet's own geology includes veins of minerals that could have formed in ancient hydrothermal systems. The real treasure isn't imagined alien tech, it's the natural evidence of a planet that once bubbled with the ingredients for life, that gleaming fleck from Curiosity. It's a reminder that we're already leaving our fingerprints on Mars, one tiny, reflective piece at a time. Of all the strange formations Curiosity has spotted on Mars, few sparked as much excitement as the image it captured in May 2022, a near-perfect rectangular crevice cut into a rocky hillside, looking for all the world like a deliberate doorway. The photo, taken in Gale Crater's Mount Sharp region, showed a tall, narrow gap with unnaturally straight edges framed by shadow as if inviting something or someone to step through. Social media erupted overnight. Was this evidence of an ancient Martian civilization, a hidden entrance to subterranean tunnels? The resemblance to a man-made passage was so uncanny that even skeptics had to admit it looked like a door. But Mars has a knack for crafting illusions. Geologists quickly pointed out that what we were seeing wasn't some architectural relic, it was a textbook example of a shear fracture. On Earth, similar cracks form in cliffs and canyon walls when layers of rock, stressed by shifting tectonic plates or erosion, suddenly split under pressure. On Mars, where quakes and ancient impacts have rattled the crust for billions of years, these fractures are even more common. The doorway is likely just a lucky or unlucky break where a vertical slab of rock peeled away from the cliff face, leaving behind a gap with deceptively clean edges. What makes this formation so mesmerizing is the interplay of light and perspective. The crevices' sharp angles and uniform width are exaggerated by the angle of the sun, casting deep shadows that heighten the illusion of symmetry. From another viewpoint or at a different time of day, it might look like just another jagged crack. Even the lintel above the gap, the part that made it seem so door-like, is probably a harder layer of rock that resisted erosion, creating the appearance of a deliberate overhang. Here's where it gets even more fascinating. Similar fractures exist all over Mars, but most don't catch our attention because they're less photogenic. The doorway stands out because it taps into a universal human instinct. We're wired to seek patterns, especially ones that suggest order or intention. It's the same reason we see faces in mountains or animals in clouds. Our brains are primed to find meaning, even in randomness. On Mars, where every rock and ridge feels alien, that tendency goes into overdrive. But the real story isn't the doorway itself. It's what the formation tells us about Mars' geologic activity. The fact that such clean fractures exist hints at a dynamic past where seismic shifts or volcanic forces reshaped the landscape in dramatic ways. Some researchers speculate that liquid water or even underground ice might have weakened the rock over time, making it more prone to splitting. Others point to the constant tug of Mars' gravity, which, though weaker than Earth's, still stresses the planet's crust in ways we're only starting to understand. So while the doorway isn't a portal to some lost Martian city, it's still a window into the planet's hidden rhythms. Every crack, every crevice is a clue, a silent witness to the forces that have sculpted this world over eons. And who knows, if we ever do find real signs of life on Mars, they might not be grand pyramids or towering statues, but something far subtler. A fossilized ripple in the mud, a vein of minerals left by microbes, or maybe, just maybe, a doorway we didn't have to imagine. If there's one thing Mars excels at, it's making the impossible seem real, like the time Curiosity rover sent back a photo of what looked like a spoon floating in midair. Yes, you heard that right. Perched above the dusty Martian surface was a slender, curved rock, balanced so perfectly it appeared to defy gravity. The image went viral, with some joking about Martian chefs leaving their utensils behind, while others wondered if wind erosion had sculpted a natural wonder unlike anything on Earth. But here's the kicker. It's not actually floating. The spoon is a masterclass in optical trickery, a combination of shadows and camera angles that turn a mundane rock into something extraordinary. The handle is likely a thin, eroded spire of rock still attached to a larger formation just out of frame, while the bowl of the spoon is a wind-carved overhang. The harsh sunlight streaming in from the side casts a deep shadow beneath it, creating the illusion that the entire structure is hovering. On Earth, we see similar effects in places like Bryce Canyon, where hoodoos, those towering, delicate rock spires, can look like they're suspended in air when photographed from just the right angle. What makes this Martian spoon so fascinating isn't just the illusion, though. It's what the rock reveals about the planet's relentless weathering. Mars' thin atmosphere offers little protection from micrometeorites or UV radiation, and its winds, though less forceful than Earth's, have had billions of years to sandblast the landscape into surreal shapes. The spoon's delicate curves suggest it's made of softer material than the surrounding bedrock, possibly volcanic ash or sedimentary layers that eroded at different rates. Over time, the wind scoured away the weaker parts, leaving behind this fragile-looking remnant. And here's where things get even more intriguing. The spoon isn't alone. Curiosity has spotted dozens of similarly improbable formations rocks that look like they're balancing on spikes, arches thinner than a pencil, and even one that resembled a crab claw. Each one is a testament to Mars' unique geology, where the rules of erosion play out without rain, rivers, or vegetation to interfere. The planet's low gravity might even help preserve these precarious structures longer than they'd last on Earth, letting them teeter on the edge of collapse for millennia. So while the spoon isn't evidence of interplanetary tea parties, it's a reminder of how Mars constantly reshapes our understanding of natural processes. It's a world where the familiar twists into the uncanny, where rocks become art, and where even the simplest snapshot can spark a sense of wonder. The next time you see a weird formation in a rover photo, take a closer look, because sometimes the most impossible things are just the universe showing off. One of the most notorious cases of Martian pareidolia started with a single Curiosity rover photo from 2014, a rock that looked for all the world like a fossilized thigh bone. There it was, lying in the dust of Gale Crater, a long, smooth shaft with what appeared to be a rounded joint at one end, eerily reminiscent of a femur. The internet went wild, with headlines screaming about potential proof of ancient Martian life, some even suggesting dinosaur-like creatures once roamed the red planet. But NASA quickly stepped in to cool the speculation, explaining that while the shape was uncanny, this was simply another trick of erosion and lighting, a rock carved by wind into a familiar form, not the remnants of some long-dead organism. What makes this particular illusion so compelling isn't just the shape, it's the context. Mars was once a warmer, wetter world, and if life ever existed there, fossils wouldn't be out of the question. But identifying them from orbit or rover imagery is a monumental challenge. On Earth, paleontologists rely on fine details, microscopic cellular structures, chemical signatures, or the way bones integrate with surrounding sediment, none of which are easily visible in grainy, sun-washed photos from millions of miles away. Even if Mars did have fossils, they'd likely be microbial, not towering reptilian skeletons. The thigh bone rock, in reality, is a textbook example of how wind shapes Martian geology. Over millennia, gusts carrying fine sand have sandblasted certain rocks into smooth, elongated forms, while leaving others pitted and jagged. The process is relentless. Mars' thin atmosphere means less friction to slow those abrasive particles, allowing them to sculpt stone with surprising precision. Similar formations exist in Earth's deserts, like the streamlined ventifacts found in Antarctica or the American Southwest. But Mars' lower gravity and lack of vegetation let these features grow even more exaggerated. Yet the debate didn't end with NASA explanation. Some researchers pointed out that while the bone-like rock might not be biological, it does raise a fascinating question. How would we recognize a fossil on Mars if we saw one? The tools we've sent rovers with, cameras, lasers, and drills, are designed for geology, not paleontology. Even something as obvious as a shell or a leaf imprint could be dismissed as just another weird rock if the context wasn't clear. That's why future missions, like the Mars Sample Return Project, are so critical. Bringing pieces of Mars back to Earth would let scientists scrutinize them with tools far more sensitive than anything a rover can carry. The thigh bone illusion isn't just a quirky footnote, it's a reminder of how carefully we need to interpret the red planet's secrets. Every strange shape is a Rorschach test, revealing as much about our hopes as it does about Martian history. And who knows, maybe one day we'll find something that isn't a trick of the light, but until then, the Femur rock stands as a monument to both our curiosity and the universe's talent for keeping us guessing. In the barren, wind-swept plains of Mars, Curiosity rover once spotted something that looked like it belonged in a desert garden, a delicate, flower-like structure no larger than a penny clinging to the rust-colored rock. This wasn't some alien blossom swaying in the breeze, but a tiny mineral formation with petal-like projections, so intricate it seemed almost handcrafted. The internet, predictably lit up with theories, was this proof of Martian flora, a fossilized remnant of some long-lost organism. The excitement was palpable, but the truth, as always on Mars, was a blend of scientific wonder and cosmic coincidence. This Mars flower, known to researchers as the blackthorn salt, is actually a mineral deposit likely formed by water interacting with rock in the distant past. On Earth, similar structures called diagenetic crystals form when mineral-rich water seeps through porous stone, leaving behind delicate clusters as the liquid evaporates. The flower's petals are probably tiny growths of gypsum or another sulfate mineral. Their branching patterns created molecule by molecule over thousands or even millions of years. What makes this formation so special isn't just its beauty, but what it implies about Mars' environment. For minerals to precipitate into such intricate shapes, there had to be water. And not just a fleeting puddle, but groundwater persisting long enough for these slow, crystalline dances to unfold. Yet the flower's discovery sparked more than geological debate. Its organic-looking shape tapped into a deeper question. How do we distinguish between life and the lifelike? On Earth, scientists have found mineral formations so eerily biological they've been mistaken for fossils, like the desert roses of gypsum in arid regions or the iron-rich pyrite suns that resemble delicate golden daisies. These pseudofossils are nature's greatest mimics, blurring the line between chemistry and biology. On Mars, where every hint of water raises hopes for life, that line becomes even thinner. The flower isn't alive, but its existence in a place once capable of sustaining such mineral processes makes the search for actual biosignatures all the more tantalizing. Here's where it gets even more fascinating. Curiosity's instruments detected organic molecules in the same region as the flower, not proof of life, but carbon-based compounds that could be its building blocks. Some researchers speculate that formations like these might even preserve microscopic evidence of ancient microbes, their shapes or chemical traces locked in the mineral lattice. Future missions like the Mars Sample Return Project could finally settle the debate by bringing pieces of such structures back to Earth, where labs could probe them for hints of past biology. What makes the Mars flower unforgettable isn't just its scientific value. It's the way it captures our imagination. In a landscape dominated by dust and rock, this tiny, fragile thing feels like a whisper of resilience, a reminder that even in the harshest environments, nature finds a way to create something unexpected. Whether it's a mineral marvel or a signpost to deeper mysteries, one thing's certain: Mars keeps surprising us one delicate petal at a time. Even in a universe as vast as ours, some coincidences feel like they were scripted by fate, or maybe a particularly clever sci-fi writer. Case in point, the day NASA, a Mars reconnaissance orbiter, spotted a cluster of dunes in the shape of the iconic Starfleet logo from Star Trek. There they were, etched into the rusty sands of Hellas Planitia, a series of crescent-shaped Martian dunes with a central ridge perfectly mirroring the Delta Shield emblem worn by Captain Kirk and the crew of the Enterprise. The internet erupted. Had some die-hard Trekkie terraformed Mars as an homage? Was the universe winking at us? The truth, as always with Mars, lies in the mesmerizing power of natural forces. These dunes weren't sculpted by interstellar fans, they were crafted by the relentless dance of wind and sand. Martian dunes, common on both Earth and Mars, form when steady winds blow in one direction, piling sand into those trademark crescent shapes with horns pointing downwind. But what made this cluster so uncannily logo-like was a rare twist, a secondary wind pattern. Scientists theorize that gusts from another angle reshaped the dune's trailing edges, carving that central ridge and creating the illusion of a symbol millions of Star Trek fans would recognize instantly. What's fascinating isn't just the shape, it's the scale. These aren't tiny sand doodles. Some of the dunes stretch hundreds of feet across, their curves visible from space. And they're not static. Time-lapse images show dunes like these inching across Mars' surface, their forms constantly tweaked by seasonal wind shifts. The Star Trek resemblance is a fleeting accident, a celestial alignment of physics and pop culture that might vanish in another 1,000 years as the sands keep marching. This isn't the first time Mars has mirrored human iconography. From smiley face craters to heart-shaped valleys, the planet seems to delight in these visual puns. But the Starfleet dunes stand out because they tap into something deeper, our longing to find familiar stories in the stars. Star Trek's entire premise is exploration, the idea that humanity's future lies in reaching outward. To see its emblem etched onto another planet, even by chance, feels like the cosmos nudging us forward. Of course, scientists love to point out the real marvel here, the intricate physics behind dune formation. Mars' thin atmosphere means its winds are gentler than Earth's, yet they can still move massive amounts of sand over time. The Hellas Basin, where these dunes were found, is one of the windiest places on the planet, a natural laboratory for studying how alien landscapes evolve. Every ripple and curve is a clue, a snapshot of atmospheric conditions locked in granular form. So while the Star Trek dunes might not be a sign from extraterrestrial fans, they're a testament to the playful side of planetary science. Sometimes the universe serves up a coincidence so perfect, you can almost hear the Enterprise's engines humming in the background. And who knows, maybe one day, when humans finally set foot on Mars, some enterprising explorer will make a detour to Hellas Planitia, just to snap a selfie with the galaxy's most serendipitous sand sculpture. Among the countless strange features Mars has revealed, few are as hauntingly beautiful as the so-called ghost dunes, a vast, empty molds where towering sand dunes once stood, now frozen in time as hollow impressions in solid rock. These eerie formations, some stretching hundreds of feet long, look like the fossilized footprints of long-vanished giants, their curves and crests preserved with uncanny precision. The first clear examples were spotted by NASA's Mars Reconnaissance Orbiter in 2018, scattered across regions like Noctis Labyrinthus and Hellas Planitia, and they tell a story far more dramatic than their silent appearance suggests. These ghost dunes began their lives as ordinary sand dunes, shaped by ancient Martian winds into sweeping curves and steep slip faces. But then, something extraordinary happened. Volcanic ash or floodwater surged in, burying the dunes entirely. Over millennia, the sand inside these natural tombs became saturated with mineral-rich fluids, cementing the grains together into tough, erosion-resistant rock. Meanwhile, the relentless winds of Mars went to work, scouring away the softer outer material until only the hardened casts remained, standing like hollow sculptures where the dunes once towered. What makes these formations so scientifically valuable isn't just their surreal appearance, it's the clues they hold about Mars' environmental extremes. The ghost dunes' sheer size suggests the planet once had much denser air, capable of shaping and moving massive amounts of sand. Today's thin Martian atmosphere struggles to shift even small ripples, but these fossilized dunes hint at a time when winds roared with enough force to sculpt landscapes on a grand scale. Even more tantalizing is their connection to water. Some ghost dunes are found in regions that show signs of ancient flooding, their bases embedded in layers of sediment that could only have been laid down by liquid. If water played a role in their preservation, it means these dunes stood witness to a Mars that was both wind-swept and wet, a world caught between desert and deluge. And here's where the ghost dunes get even stranger. Some of their hollow interiors contain minerals like clay or sulfates, compounds that typically form in the presence of water. Could these be the remnants of shallow ponds or groundwater that once pooled inside the dunes' sheltered troughs? If so, they might have been fleeting oases in an otherwise harsh environment, temporary pockets where microbial life, if it ever existed, could have clung to survival. It's a haunting thought. These empty shells might once have cradled the very ingredients for life, their curves acting as traps for moisture and organic material. The real magic of ghost dunes lies in their duality. They're both monuments to absence and time capsules of presence, echoes of a lost atmosphere and whispers of vanished water. Every ripple preserved in their rocky skin is a snapshot of ancient weather patterns, every mineral stain a potential clue to Mars' habitability. They remind us that even the most barren landscapes were once dynamic, shaped by forces wilder than we can easily imagine. And perhaps the most humbling realization, these ghostly forms aren't unique to Mars. Similar structures exist on Earth, from the hollow sandstone dune casts of Utah to the fossilized wind-blown ridges of Namibia. But on Mars, where the processes that made them stopped billions of years ago, they feel like messages from a world that's been holding its breath, waiting for us to read the stories written in its sand. Sometimes Mars doesn't just tease our imagination, it stares right back at us. That's exactly what happened when Curiosity rover beamed back an image of a rock so eerily skull-like it sent chills through the internet. There, amid the dusty red terrain, lay what appeared to be a hollow-eyed, vaguely humanoid cranium, complete with a rounded forehead, sunken sockets, and even a jagged edge resembling a weathered jawline. The alien skull became an instant sensation, with armchair archaeologists and UFO enthusiasts declaring it proof of ancient Martian civilizations. But as with so many Martian mysteries, the truth lies somewhere between geology and psychology. This particular rock is a textbook example of pareidolia, the brain's hardwired habit of spotting familiar patterns in random shapes. It's the same instinct that makes us see dragons in clouds or the man in the moon. On Mars, where every landscape feels alien, our minds scramble to anchor themselves in the recognizable. The skull illusion is amplified by the planet's harsh lighting, where low-angle sunlight stretches shadows into dramatic hollows, turning ordinary pits into eye sockets and cracks into grimacing mouths. But let's break it down scientifically. The skull is likely a ventifact, a wind-carved rock sculpted by millennia of abrasive sandblasting. Mars' thin atmosphere might seem gentle, but its winds carry fine particles at high speeds, acting like a cosmic sandpaper that slowly chips away softer material. The rock's elongated shape suggests it once lay horizontally, with its face sculpted by relentless gusts from a consistent direction, the jaw fracture. Probably a clean break from thermal stress, as Mars' wild temperature swings cause rocks to expand and contract until they split. What makes this illusion so powerful isn't just the shape, it's the context. Humans are social creatures wired to recognize faces above all else. Our survival once depended on spotting friend or foe in the shadows. When Curiosity's camera frames a rock against the barren Martian wastes, our brains scream, "This doesn't belong here." Even though it's just another piece of a geological puzzle, yet the alien skull isn't just a quirk of perception. It's a gateway to deeper questions about how we explore. Every rover mission is, in a sense, a test of our ability to separate signal from noise. Scientists pore over thousands of images, trained to spot the subtle differences between a weird rock and a genuine anomaly. The skull reminds us how easily bias can creep in, how a single suggestive shape can overshadow volumes of mundane data. Here's the twist: Mars does have real skull-like structures, just not the kind we imagine. Fossilized bones, unlikely, but the planet's surface is littered with volcanic rocks called basaltic hornitos, which form when lava skins over and gases escape, leaving behind hollow, bony protrusions. There are also hoodoos, towering spires of eroded sediment that loom like skeletal fingers. These natural formations are haunting enough without pareidolia's help. The alien skull endures because it taps into our deepest curiosity. Are we alone? It's a Rorschach test for our cosmic anxieties, a mirror reflecting our hopes that Mars might hold more than just rocks and dust. And while this particular skull is just geology's prank, the next odd shape might not be. After all, if we ever do find proof of life on Mars, it probably won't come with a flashing neon sign. It'll be hiding in plain sight, waiting for us to see it, not as we wish it were, but as it truly is. Out of all the oddities Mars has served up over the years, few are as deceptively simple or as perfectly shaped as the so-called Mars cannonball. When Opportunity Rover rolled across Meridiani Planum in 2005, its cameras locked onto a small, dark sphere sitting on the rust-colored soil like a misplaced bowling ball. Unlike the jagged rocks surrounding it, this object was almost unnervingly round, its smooth surface catching the sunlight with geometric precision. The internet predictably had a field day. Was this some ancient Martian artillery? A cosmic musket shot frozen in time, but the truth, as usual, is a masterclass in how natural forces can sculpt the improbable. This spherical rock isn't some alien artifact, it's a geologic phenomenon with earthly cousins. Back home, we call them Moqui marbles, iron-rich concretions found scattered across the deserts of Utah. Like their Martian counterpart, these terrestrial spheres form when mineral-laden water seeps through porous rock, depositing layers of iron oxide around a central nucleus. Over time, the softer surrounding material erodes away, leaving behind these hardened orbs as if nature had a secret passion for marble making. On Mars, the process likely played out billions of years ago, when groundwater percolated through the planet's sedimentary layers, leaving behind these metallic time capsules as the climate dried up. But here's where Mars one-ups Earth, the sheer abundance of these spheres. Opportunity didn't just find one cannonball, it stumbled onto entire fields of them, some embedded in outcrops like blueberries in a muffin, others loose and scattered as if some cosmic giant had dropped a bag of marbles. Their uniformity suggests a widespread, consistent process, hinting at a time when liquid water was far more than just a fleeting presence on the red planet. And while most are small, no bigger than a grape, their perfect shapes speak to a patient, meticulous formation, where chemistry and time conspired to create something almost too precise to feel random. Scientists suspect these spheres owe their symmetry to the way minerals crystallize in fluid-saturated environments. As dissolved iron and oxygen interact, they precipitate out in concentric layers, building outward evenly in all directions. Mars' low gravity might have even helped, allowing the concretions to grow more perfectly spherical than they would under Earth's stronger pull. Wind erosion later sanded them down, polishing their surfaces into those eerie, cannonball-smooth finishes. What's truly mind-bending is how these unassuming spheres rewrite Mars' history. Their iron-rich composition points to a wetter, chemically active past, one where groundwater not only existed but lingered long enough to sculpt the landscape on a microscopic scale. Some researchers even speculate that if microbial life ever existed on Mars, these concretions could have acted as tiny shelters, their porous interiors trapping and preserving organic molecules. Future missions might one day crack one open, searching for hidden clues in their mineral layers like tree rings recording an alien climate. So while the Mars cannonball isn't some interstellar weapon, it's a weapon against ignorance, a small, round testament to the planet's dynamic past. It reminds us that even the simplest shapes can hold epic stories, and that sometimes the most extraordinary discoveries come in the most ordinary packages. After all, in a universe where wind and water can turn dust into geometry, who needs aliens to explain the uncanny? Nature's already the best sculptor out there. When Curiosity Rover first glimpsed that sharp, angled rock formation in Gale Crater, the internet collectively gasped. Was this a pyramid on Mars? The structure's unnaturally straight edges and triangular silhouette looked so precise, so deliberate, that it seemed to defy the randomness of nature. For a brief, thrilling moment, the idea of ancient Martian architects didn't feel quite so far-fetched. But as with so many Martian mysteries, the truth lies in the patient handiwork of the planet's most relentless sculptor, the wind. This so-called Mars pyramid is actually a ventifact, a rock carved into its geometric shape by millennia of abrasive winds. On Earth, ventifacts form in deserts where sand-laden gusts sandblast exposed boulders into faceted, often angular forms. But Mars takes this process to another level. With atmospheric pressure just 1% of Earth's, its winds may not howl as fiercely, but they've had billions of years to work uninterrupted by rain or vegetation. The result, rocks polished into shapes so crisp they look chiseled. The pyramid's flat planes likely align with prevailing wind directions, its sharp ridges marking where softer material was stripped away grain by grain. What makes this formation stand out isn't just its shape, it's the context. Gale Crater was once a lake bed, its sediments layered like a geologic cake. When winds eroded these layers, they exposed harder rock nodules that resisted weathering. The pyramid might be one such survivor, a durable remnant left standing while everything around it slowly vanished. High-resolution images reveal subtle pitting and fluting on its surface, telltale signs of wind abrasion, and its base blends seamlessly into the surrounding bedrock, ruling out any possibility it was placed there. Yet the pyramid's allure isn't just scientific. It taps into something primal in us, the same instinct that made early explorers see the Sphinx in Egypt's limestone or the pyramids of Giza as celestial markers. We're pattern-seeking creatures wired to find meaning in symmetry. When faced with a landscape as alien as Mars, that instinct goes into overdrive. Every right angle, every smooth face feels like a signpost, a whisper that we're not alone. The real magic, though, lies in what ventifacts tell us about Mars' enduring dynamism. These aren't static monuments, they're snapshots of an ongoing process. Time-lapse images from orbit show dunes creeping across the surface, proving the wind still reshapes the planet today. The pyramid might look ancient, but it's part of a living landscape, one where change unfolds grain by grain. And who knows, maybe one day when humans finally walk those rust-colored plains, they'll find their own faces reflected in the wind-carved stones, not as alien artifacts but as mirrors to our endless curiosity. Out in the vast, sun-baked plains of Mars, there's a crater that doesn't play by the usual rules. It's shaped like a tadpole. Not the perfectly round impact basins we're used to seeing, but a strange, elongated depression with a long, winding tail trailing behind it, as if something had dragged itself across the surface before coming to rest. This bizarre formation, spotted by NASA, a Mars reconnaissance orbiter, looks so out of place that researchers initially struggled to explain it. How does a crater, typically the result of a meteorite strike, end up looking like a cosmic polywog? The answer lies in Mars' watery past. Unlike Earth, where most ancient riverbeds and lakes have been erased by tectonic activity or vegetation, Mars preserves its geologic scars with eerie clarity. The tadpole crater's peculiar shape isn't from an impact at all, it's the handiwork of liquid water. Scientists believe this feature started as a simple pit, likely formed by ground collapse or volcanic activity. Then, billions of years ago, when Mars was a wetter world, water burst through the area in a sudden, violent flood. The torrent carved a sinuous channel, the tail, as it raced across the landscape, scouring the terrain and sculpting the pit into its tadpole silhouette. What we're seeing is essentially a fossilized flash flood frozen in time. What makes this formation so special isn't just its shape, it's the way it challenges our assumptions. Most Martian channels are thought to have formed slowly, over centuries or millennia, as meandering rivers etched their paths, but the tadpole crater's tale is different. Its steep walls and lack of tributaries suggest a single catastrophic event, a deluge powerful enough to reshape the land in hours or days. Imagine a dam breaking on ancient Mars, releasing a wall of water that tore through rock like it was wet paper. The force would have been unimaginable, carrying boulders the size of houses and leaving behind scars that last for eons. Here's the twist: the tadpole's tail isn't just a relic, it's a time capsule. Orbital scans reveal mineral deposits along its length, including clays and sulfates that typically form in the presence of water. These aren't just passive stains, they're chemical breadcrumbs, clues to the composition of Mars' ancient floods. Some researchers even speculate that if microbial life ever existed on Mars, these mineral-rich channels could have been temporary refuges, sheltered pockets where organisms clung to survival between droughts. Yet the real marvel is how much this odd little crater tells us about Mars' climate swings. The tadpole's existence implies a world that could flip between extremes, from parched deserts to raging floods in geologic snapshots. Earth has its own examples of such catastrophes, like the channeled scablands of Washington state, carved by Ice Age megafloods. But on Mars, where these features stay pristine for billions of years, the story feels sharper, more immediate. Every curve of that tail is a sentence in a planetary memoir written in water and stone. So while the tadpole crater might not be as flashy as a pyramid or as uncanny as a floating spoon, it's proof that Mars' strangest shapes often hold the deepest secrets. This isn't just a quirky landform, it's a ripple from an ancient apocalypse, a reminder that even the quietest corners of the red planet have lived through chaos we can barely fathom. And somewhere out there, in the dust and the silence, there might be more tadpoles waiting, each one a whisper from a time when Mars wasn't just a desert, but a world of sudden, violent change. Mars loves its optical illusions, and just when we thought we'd seen them all, another uncanny spoon-shaped rock appeared, this time perched precariously on the edge of a cliff like some cosmic utensil about to take a dive. Curiosity rover snapped this latest floating spoon in 2020, and just like its predecessor, the image sent the internet spiraling into questions. How could a rock that thin defy gravity? Was it somehow suspended by invisible forces, or had Martian winds sculpted it into an impossible balancing act? The truth is even more fascinating than fiction. This spoon isn't floating, it's clinging. The handle is actually still attached to a larger rock formation just out of frame, eroded over millennia by wind into that slender, curved shape. The illusion of suspension comes from the angle of the sunlight, which casts a shadow directly beneath the overhang, hiding the connection point. On Earth, we see similar tricks in places like Arches National Park, where sandstone fins appear to hover when photographed from certain perspectives. But Mars' weaker gravity, just 38% of Earth's, lets these delicate structures survive much longer without collapsing, making them even more photogenic. What's remarkable isn't just the spoon's shape, but what it reveals about Mars' geology. The rock is likely basalt, a volcanic material common on the planet. Basalt is dense and hard, but over billions of years, even the toughest stone surrenders to the planet's relentless sandblasting winds. The spoon's smooth curves suggest it was carved by particles moving in a consistent direction, like a sculptor patiently chiseling away softer layers. Meanwhile, the bowl of the spoon might have formed along a natural fracture line in the rock where erosion accelerated, leaving behind that perfect concave curve. Here's where it gets even wilder. This isn't just one quirky formation, it's part of a pattern. Curiosity has spotted dozens of these gravity-defying illusions, rocks that look like they're balancing on spikes, arches thinner than a pencil, even a formation nicknamed the shark fin for its razor-thin profile. Each one is a testament to Mars' unique erosion rules, where wind acts like an artist with endless time and patience. Without rain or tectonic activity to disturb the process, these features evolve with surreal precision, turning entire landscapes into galleries of natural abstract art. But beyond the wow factor, these spoons and spires serve a scientific purpose. Their shapes record the planet's atmospheric history, hinting at wind speeds, directions, and even past climate shifts. Some researchers study them like tree rings, reading the layers to reconstruct ancient weather patterns. Others see them as potential markers for softer sedimentary rocks, which might preserve traces of organic material. After all, if wind carved these fragile forms, what else might it have exposed or concealed? So while the floating spoon isn't evidence of Martian kitchens, it's a masterclass in how geology bends perception. It reminds us that Mars isn't just a desert, it's a workshop, where time and physics collaborate to create wonders that challenge our eyes and ignite our imagination. And somewhere out there, in the dust and the silence, another spoon might be forming, waiting for a rover's camera to catch it mid-illusion just long enough to make us question everything we think we know. Tucked away in Curiosity, Rover's vast gallery of Martian snapshots is an image that stopped researchers mid-scroll, a slender, jagged spike jutting from the dust like a fossilized lightning bolt. This eerie protrusion, quickly nicknamed the Mars stalagmite, looks like it was plucked straight from an underground cave on Earth, its rough texture and pointed tip defying the barren landscape around it. At first glance, it's hard to believe something so delicate could endure Mars' punishing winds, let alone form naturally. But this needle-like wonder isn't just a trick of the light, it's a window into the planet's volatile past. The most striking parallel to Earth's stalagmites, those upward-growing mineral pillars found in limestone caves, hints at a watery origin. On our planet, stalagmites form drip by drip over millennia, as mineral-rich water seeps through cave ceilings, depositing calcium carbonate on the floor below. But Mars' thin atmosphere and lack of liquid water make that process unlikely here. So how did this spike take shape? One compelling theory points to volcanic activity. Basaltic lava, rich in iron and magnesium, can sometimes harden into spiny formations called lava stalactites, when gas bubbles burst through cooling flows, leaving behind hollow tubes that erode into sharp points over time. If the Mars stalagmite formed this way, it could be a relic of ancient lava tubes, their ceilings long collapsed, exposing this solitary sentinel. Then there's the mineral angle. Mars is littered with sulfate deposits, salts left behind by long-vanished water. When these minerals dissolve and recrystallize, driven by temperature swings or residual groundwater, they can grow into fibrous or needle-like structures. On Earth, we see similar formations in deserts like Chile's Atacama, where gypsum crystals sprout from the arid soil like alien flora. The stalagmite's layered texture suggests it might have grown incrementally, its minerals deposited in cycles as Mars' climate oscillated between wet and dry eras. But here's the twist: wind erosion likely played the final sculpting role. Mars' relentless sandblasting could have whittled a larger rock formation down to this fragile spine, like a cosmic artisan carving a masterpiece from a slab of stone. The spike's survival is a testament to its composition, something harder than the surrounding material, resisting erosion while everything else wore away. What makes this formation so mesmerizing isn't just its origin story, it's the questions it raises. Could similar spikes hide in caves or overhangs, shielded from the wind? If so, they might preserve clues about Mars' subsurface, where conditions could have once been friendlier to life. Future missions equipped with ground-penetrating radar or even drones might target these spires, probing them for mineral traces or trapped gases. For now, the Mars stalagmite stands as both a geologic oddity and a symbol of the planet's hidden complexity. It reminds us that even in the harshest environments, nature finds a way to create the unexpected, one fragile, defiant spike at a time. And somewhere out there, in the dust and the silence, more of these silent sentinels might be waiting, each one a puzzle begging to be solved. Of all the strange geological features Mars has revealed, few have sparked as much playful debate as the so-called Mars waffle. When NASA Mars Reconnaissance Orbiter captured images of this peculiar grid-like pattern in Utopia Planitia, the Internet collectively tilted its head. Was this nature's geometry or something more deliberate? The formation stretches across the landscape like a cosmic breakfast imprint, its perfectly intersecting ridges forming a lattice of near-identical squares. At first glance, it's hard not to wonder if some interstellar chef pressed a giant iron into the Martian soil, but science, as always, has a more grounded explanation. The waffle pattern is likely the result of either ancient lava flows or dried mud cracking under extreme conditions. In the case of lava, scientists propose that as molten rock spread across the surface, it cooled unevenly, creating a network of contraction fractures. These cracks then filled with fresh lava, leaving behind raised ridges in a grid formation, essentially a planetary-scale version of the way mud cracks in a dried-up puddle, but forged in fire rather than water. Alternatively, if mud was the artist, the pattern could be a relic from a time when water saturated the soil before rapidly evaporating in Mars' thin atmosphere, leaving behind polygonal cracks that hardened over millennia. What's fascinating is how precise the waffle appears. The ridges are remarkably uniform, with angles so sharp they seem almost machined. This kind of symmetry isn't unheard of in nature. Think of the hexagonal basalt columns at Giant's Causeway in Northern Ireland or the tessellated salt flats of Death Valley. But Mars' version takes it a step further, with a regularity that feels almost mathematical. Some researchers speculate that the planet's lower gravity and lack of tectonic activity allowed these patterns to form with minimal distortion, preserving their crisp edges in a way that's rare on Earth. Of course, the waffle's uncanny resemblance to human-made structures didn't go unnoticed. Online forums buzzed with theories about buried alien cities, ancient landing pads, or even a planetary-scale energy grid. The formation's location, Utopia Planitia, a vast plain thought to harbor subsurface ice, only fueled speculation. Could this be the remains of some lost infrastructure designed to harness water or stabilize the terrain? It's a tantalizing thought, but the truth is likely far simpler. Still, the waffle's existence raises a provocative question. How would we even recognize artificial structures on Mars if they existed? When nature can produce shapes this orderly, the line between geology and architecture blurs. The real magic of the Mars waffle lies in what it tells us about the planet's geological diversity. It's a reminder that Mars isn't just a monotonous desert. It's a world of hidden textures where every plain and crater holds surprises. Future missions might one day scrape a sample from those ridges, analyzing their mineral content to settle the lava versus mud debate once and for all. Until then, the waffle remains a delicious enigma, a crisp, grid-shaped clue to the forces that shaped Mars, and a testament to the human mind's endless appetite for wonder. Whether forged by fire or dried by time, it's proof that even in the silence of space, nature has a flair for the artistic. One of the most perplexing images from Mars shows what looks like a discarded vinyl record half buried in the dust, a thin, unnaturally circular disk standing out against the rusty terrain. When Curiosity rover beamed back this photo in 2017, eagle-eyed viewers immediately spotted the bizarre formation, dubbing it the Mars disk. The object appeared almost too perfectly rounded, its edges crisp against the surrounding rubble, sparking instant speculation. Was this some ancient artifact? A fragment of machinery, or just another of Mars' relentless optical illusions? The answer lies in the planet's layered geology. The disk isn't a manufactured object, it's a textbook example of what happens when sedimentary rock weathers in extreme conditions. On Earth, similar formations occur in places like Utah's sandstone cliffs, where alternating layers of hard and soft rock erode at different rates, leaving behind flaky, disc-like protrusions. On Mars, the process is amplified by the planet's bone-dry climate and relentless winds. The disk likely began as part of a larger rock formation, its layers compressed over millennia. As wind-blown sand scoured the surface, softer material wore away faster, leaving behind a harder, more resistant layer that eventually fractured along its natural bedding planes. Over time, this thin sheet broke free, tumbling or sliding until it came to rest at an angle that made it seem artificially placed. But what makes this particular disk so mesmerizing is its deceptive symmetry. The human eye is trained to spot irregularities, so when nature produces something this geometrically satisfying, it feels intentional. The illusion is heightened by the disk's shadow, which accentuates its flat profile and clean edges. From another angle or under different lighting, it might just look like another broken rock, proof that perspective shapes how we interpret the unknown. What's scientifically valuable about formations like this isn't their mystery, but what they reveal about Mars' geological history. The disk's layered structure hints at a time when sediments accumulated in cyclical patterns, perhaps from ancient lakes or rivers that dried up and returned repeatedly. Each flake is like a page in a geologic diary, recording shifts in climate or water flow. Some researchers even speculate that such layers could trap organic compounds, preserving them like a cosmic time capsule. Yet the Mars disk also underscores a bigger challenge in planetary exploration, distinguishing the extraordinary from the merely unfamiliar. Every rover mission is a balancing act between curiosity and caution, where scientists must weigh every strange shape against known geologic processes before jumping to conclusions. It's a reminder that Mars, for all its strangeness, operates by the same physical laws as Earth, just with a different set of tools. Wind replaces water, time stretches longer, and the results can look downright alien. So while the disk isn't evidence of a lost Martian civilization, it's a testament to the planet's ability to spark wonder. In a landscape devoid of life, these accidental artworks become landmarks, not just for rovers but for the human imagination. And somewhere out there, buried in the dust or perched on a slope, another disk might be waiting, ready to turn a routine photo into the next great cosmic Rorschach test. Among the twisted rock formations and wind-scoured plains of Mars, Curiosity rover once stumbled upon something that looked startlingly out of place, a cluster of elongated, segmented stones that bore an uncanny resemblance to petrified logs. Dubbed Martian wood by eager observers, these dark, cylindrical fragments seem to lie scattered across the dust like remnants of an ancient forest frozen in time. The internet buzzed with theories. Had Mars once been lush with towering trees? Were these the skeletal remains of a lost ecosystem? But as with so many Martian mysteries, the truth is woven from geology, not biology. These log-like rocks are textbook examples of sandstone concretions, mineral formations that arise when water percolates through porous sediment, depositing layers of hard material around a central nucleus. On Earth, similar structures form in places like Utah's Navajo sandstone, where iron-rich fluids leave behind bulbous or tube-shaped concretions that weather out of cliffs like fossilized branches. On Mars, the process likely played out billions of years ago, when groundwater laced with minerals like hematite or silica seeped through loose volcanic ash or sandy deposits. Over time, these fluids cemented certain patches into dense, erosion-resistant logs, while the surrounding softer material wore away, leaving the harder forms exposed. What gives these formations their lifelike appearance is a quirk of erosion. Wind-blown sand acts like a sculptor's chisel, carving parallel grooves and ridges along the concretion's lengths, details that mimic the fibrous texture of wood grain. Some even exhibit knobby protrusions that resemble broken branches, heightening the illusion, but the key distinction lies in their composition. Petrified wood on Earth is organic, its cellular structure replaced by minerals over millions of years. Martian wood, however, is purely inorganic, its patterns born from the mechanical forces of wind and water, not the growth rings of living organisms. The real intrigue lies in what these rocks reveal about Mars' watery past. Their iron-rich makeup suggests they formed in an environment where liquid water was not just present but chemically active, circulating through the subsurface long enough to create such intricate mineral deposits. Some researchers speculate these concretions might mark ancient groundwater channels or even the edges of long-vanished lakeshores, their shapes preserving clues about the flow and chemistry of Mars' primordial fluids. Yet the allure of Martian wood isn't just scientific, it's psychological. Our brains are wired to seek the familiar in the alien, and these rocks tap into a deep-seated longing for Mars to feel less barren. They're nature's Rorschach test, reflecting our hopes back at us. But perhaps the most profound lesson here isn't about what these formations aren't, but what they are, proof that even in a lifeless desert, the universe has a flair for artistry, crafting echoes of Earth in stone and wind, a reminder that beauty thrives in the unlikeliest corners of the cosmos. Even the most serious Mars researchers have to chuckle when the planet serves up something like the Mars Iguana, a rock formation so strikingly reptilian, you'd swear it was sunning itself on a crimson beach. When Curiosity rover captured this particular snapshot in 2013, the internet instantly latched onto the uncanny resemblance. There lay a craggy, elongated boulder with a tapered snout, raised ridges mimicking spines along its back, and even what looked like stubby legs tucked beneath its body. For a fleeting moment, it seemed Mars might harbor more than just microbes. Maybe prehistoric-looking creatures still roamed the dust-choked canyons. But this scaly mirage is yet another masterpiece of pareidolia, that quirky trick our brains play when faced with ambiguity. On a planet where every shadow and stone feels alien, we instinctively search for the familiar, and what's more familiar than the primal silhouette of a lizard? The Iguana rock's lifelike appearance stems from a perfect storm of lighting and erosion. Late afternoon sunlight stretches shadows into dramatic contours, deepening the crevices that form its eyes and mouth, while eons of wind have polished its surface into smooth, organic-looking curves. Flip the image upside down or view it from another angle, and the spell breaks. It's just another volcanic boulder, its shape molded by random fractures and sandblasting. What makes the Iguana more than just a funny optical illusion is what it teaches us about the challenges of exploring Mars remotely. Rover cameras capture two-dimensional images from fixed perspectives, flattening complex terrain into snapshots ripe for misinterpretation. Back on Earth, geologists can walk around a puzzling rock, tap it with a hammer, or examine its layers in cross-section. On Mars, we're left squinting at pixels, relying on shadows and educated guesses. This limitation isn't just a curiosity, it directly impacts the search for life. If a simple rock can mimic a living creature so convincingly, how much harder will it be to spot genuine fossils or microbial structures in blurry rover images? The Iguana also highlights a cultural divide in how we view Mars. Scientists see a fascinating geological puzzle, a chance to study wind patterns or volcanic history. The public, meanwhile, often sees a stage for cosmic storytelling, where every odd shape becomes a character in an interplanetary drama. This tension isn't trivial. It fuels public interest in space exploration while occasionally frustrating researchers who must temper excitement with meticulous analysis. Yet beneath the whimsy lies a profound truth. Mars does have real iguanas, just not the kind we imagine. The planet's surface is studded with volcanic features like ropey pahoho lava, which cools into twisted reptilian textures. There are also wind-carved ridges that slither across dunes like fossilized snakes, and mineral veins that branch like scales under microscopic examination. The Iguana rock may be a trick of the eye, but it's a gateway to appreciating Mars' authentic complexity, a world where geology wears 1,000 disguises, each more intriguing than the last. One of Mars' most hauntingly beautiful phenomena isn't a rock or a crater. It's a series of dark, sinuous streaks cascading down dusty slopes like ghostly jellyfish tentacles. These eerie formations, captured by orbiters like MRO, appear seasonally on the faces of Martian dunes, their inky tendrils stretching hundreds of feet across the rust-colored terrain. At first glance, they seem almost alive, a colony of spectral sea creatures clinging to the sands. But the truth behind these Mars jellyfish is a fascinating interplay of physics and planetary extremes. These streaks are the scars of dust avalanches triggered by the subtle dance of Martian seasons. As winter's carbon dioxide frost blankets the dunes, sunlight penetrating the translucent ice heats the dark sand beneath. This trapped warmth builds pressure until the ice sublimates, transforming directly from solid to gas, and explosively destabilizes the slope. The result: a cascade of fine dust roaring downhill, revealing the darker substrate beneath the surface like a brushstroke on a canvas. The tentacles are the paths of these miniature avalanches, their feathery tips marking where the collapsing material eventually slows to a stop. What makes these formations so mesmerizing is their fleeting nature. Unlike most geologic features that change over millennia, jellyfish streaks emerge and fade within weeks. Orbiter images have captured their entire life cycle: pristine slopes in early spring, then the sudden bloom of dark tendrils as the frost retreats, followed by gradual fading as winds redistribute lighter dust across the exposed surfaces. It's a reminder that Mars, for all its apparent stillness, is a world of quiet dynamism where even the tiniest shifts in temperature can rewrite entire landscapes. Yet the jellyfish aren't just pretty patterns, they're scientific gold mines. Their shapes reveal hidden details about wind direction, slope stability, and even the composition of the dunes themselves. Some researchers speculate the dark streaks might expose layers of volcanic ash or magnetite-rich sand, materials that could hold clues to Mars' climatic past. Others see them as natural laboratories for studying granular flows in low gravity, offering insights that could one day help predict landslides on Earth or design safer lunar habitats. The most tantalizing question, though, is whether these streaks could hint at something even more extraordinary. On Earth, similar-looking features called recurring slope lineae are linked to briny water seeping to the surface, though Mars jellyfish are strictly dry, frost-driven events. Still, their existence proves how easily small changes can reshape the planet, raising the possibility that other transient phenomena, perhaps even ones involving liquid, might be hiding in plain sight. So while these jellyfish won't sting or swim, they pulse with a different kind of life, the quiet heartbeat of a planet that's never quite asleep, where dust and ice perform their slow ballet under a pale pink sky. And every spring, when the light returns, they bloom again, silent, dark, and utterly alien. Of all the strange sights Curiosity rover has captured on Mars, few sparked as much instant speculation as the so-called Mars traffic light, 3 bright, perfectly aligned spots glowing against the dusty terrain like some alien signaling device. When this image beamed back to Earth in 2014, the internet lit up with theories. Was this a beacon left by an ancient civilization, some kind of extraterrestrial road marker? The 3 luminous dots, spaced at eerily even intervals, seemed almost too deliberate to be natural, but science quickly stepped in with a far simpler explanation. Those glowing spots weren't anything buried in the Martian landscape. They were likely lens flares caused by sunlight bouncing off Curiosity's own camera optics. Just like how a photographer on Earth might catch streaks of light when shooting toward the sun, the rover's cameras can produce similar artifacts when the angle is just right. The traffic light's perfect alignment, a trick of perspective where the camera's internal reflections lined up in a row, creating the illusion of something out there on the rocks. What makes this phenomenon so fascinating isn't the debunking, it's the way it plays with our perception of distance and scale. In the original image, the dots appear to sit on a distant ridge, giving the impression they're part of the terrain. But lens flares are an internal effect, meaning those bright spots exist only inside the camera's imaging system, not on Mars itself. It's a cosmic magic trick where light bends and bounces in ways that fool even careful observers. Yet the intrigue doesn't end there. Some researchers propose an alternative theory. The spots could be actual reflections from glossy rocks on the surface. Mars has plenty of smooth, light-colored stones, volcanic glass, or silica-rich formations that can catch the sun just right, flashing like tiny mirrors. If that's the case, the traffic light might be a rare alignment of natural reflectors, all glinting simultaneously under the same intense sunlight. The real lesson here is how easily Mars can turn the mundane into the extraordinary. A routine camera quirk or a few shiny rocks becomes a riddle wrapped in a mystery, simply because it's happening millions of miles away on a world we're still learning to interpret. Every strange glint or odd shadow becomes a Rorschach test for our curiosity, reflecting back whatever we're primed to see, whether that's alien technology or the quiet poetry of physics at work. And who knows, maybe one day we'll find a real traffic light on Mars, not as a beacon from lost civilizations, but as some bizarre geological formation that does resemble a signal. After all, the universe has a sense of humor. Until then, these three little dots remain a playful reminder. Sometimes the most ordinary things become extraordinary when viewed through the lens of another world. Just when you thought Mars couldn't get any stranger, along came the Mars crab, a shadowy figure lurking in a rover's photograph that sent the internet into a frenzy. In 2015, Curiosity's masked camera captured an image where its own shadow stretched across the dusty terrain, but tucked within that silhouette was a shape that looked anything but robotic. There, nestled in the rover's elongated outline, was a spindly, crab-like form with what appeared to be multiple legs and a rounded body, poised as if ready to scuttle out of frame. Social media erupted with theories. Had Curiosity stumbled upon a Martian crustacean? Was this proof of life hiding in plain sight? The reality, as usual, is a masterclass in how light and shadow conspire to fool us. The crab is nothing more than a jagged rock fragment, its edges catching the sunlight at just the right angle to create the illusion of segmented limbs. The rover's low perspective and the harsh Martian lighting amplified the effect, turning random bumps and crevices into what looked like claws and a carapace. It's the same phenomenon that makes us see faces in clouds or animals in mountain ranges, only here. The stage is an alien world and the stakes feel cosmic. What's fascinating isn't just the illusion itself, but the fervor it ignited. The Mars crab became a viral sensation, with forums dissecting every pixel, some even claiming NASA was cropping images to hide the truth. This wasn't just pareidolia, it was a cultural moment, revealing how deeply we yearn for Mars to feel alive. Crabs, after all, are earthly survivors, scuttling through deep sea vents and tidal pools with uncanny resilience. To imagine them on Mars taps into a primal hope. If something so familiar could exist there, maybe the planet isn't so hostile after all. Scientists, of course, had a field day with the crab's anatomy. The legs were likely wind-carved ridges, their scalloped edges shaped by centuries of abrasive sand. The body might have been a harder nodule of volcanic rock, resistant to erosion while the surrounding material wore away. And that eerie sense of movement, pure psychology. Our brains are wired to detect potential threats, and a crouching shape triggers ancient instincts even when it's just geology's whimsy. Yet the Mars crab isn't just a cautionary tale about overactive imaginations. It's a reminder of how much we still don't know. While this particular crustacean was a rock, the debate it sparked highlights a genuine challenge. If life did exist on Mars, what would it look like? Earth's extremophiles, creatures thriving in acidic hot springs or Antarctic ice, prove life can take bizarre forms. Future missions might one day find something truly crab-like in structure, adapted to Mars' harshness. Until then, the crab remains a funhouse mirror, reflecting our curiosity back at us, distorted, exaggerated, but undeniably alive. So while the Mars crab wasn't a galactic breakthrough, it was a cultural one. In a landscape devoid of sound or motion, it gave us a moment of shared wonder, a collective what-if that transcended labs and headlines, and who knows? Maybe one day a rover will spot something scuttling, not a trick of the light, but the real deal. Until then, the crab lingers in our minds, a playful ghost in the machinery of exploration. Among the countless rocks littering Mars' surface, Curiosity rover once spotted something so human-like, it stopped scientists in their tracks, a tiny, shadowy figure standing alone in the dust, no taller than a few inches. The so-called Mars statue looked eerily like a crude figurine with a rounded head, slender shoulders, and even what appeared to be outstretched arms. For a moment, it was impossible not to wonder, had some ancient civilization left a sculpture behind, or was this the universe's most elaborate prank? The truth is a masterclass in how wind and time can collaborate to create the uncanny. This statue-like rock is almost certainly a ventifact, a stone sculpted by millennia of abrasive sandblasting. On Mars, where winds carry fine particles at high speeds but lack the force to topple larger rocks, erosion becomes an artist with endless patience. The statue's smooth contours and tapered shape suggest it was once part of a larger formation, gradually whittled down as softer material was stripped away grain by grain. Its arms might be remnants of a harder mineral vein that resisted erosion, while the head could be a nodule of denser rock that weathered more slowly than its surroundings. What we're seeing isn't artistry, it's attrition, a slow-motion performance where the sculptor is the Martian atmosphere itself, but the statue's power lies in its ambiguity. From one angle, it's just another rock, from another, it's a silhouette that feels intentional. This duality taps into something primal in human psychology. Our brains are hardwired to recognize human forms. It's why we see faces in electrical outlets or figures in flickering shadows. On Mars, where every landscape feels alien, this instinct goes into overdrive. The statue isn't just a rock, it's a Rorschach test for our longing to find connection in the cosmos. Historically, this phenomenon isn't new. Earth has its own statues carved by wind and water. From the Sphinx-like formations in Cappadocia to the eerie moai of Rapa Nui, which early European explorers initially believed were the work of some lost super-civilization. The difference: on Mars, we're seeing these illusions unfold in real time through rover cameras, with no ability to walk around the rock and break the spell. Every image is a frozen moment, a single frame in a geologic process too slow for human perception. What's scientifically intriguing isn't the statue's shape, but what it reveals about Mars' erosion patterns. The rock's smoothness suggests consistent wind direction over centuries, while its survival amid finer dust hints at a localized wind shadow where gusts were deflected. Studying formations like this helps scientists map ancient atmospheric conditions, clues to how Mars' climate has shifted from a thicker, wetter past to today's thin, desiccated state. Yet the statue's legacy isn't just geological, it's cultural. Moments like this remind us that exploration isn't just about data, it's about storytelling. The human mind thrives on narrative, and Mars, with its silent deserts and enigmatic rocks, is the ultimate blank canvas. The statue isn't proof of aliens, but it is proof of something equally profound: our relentless drive to project meaning onto the unknown, to populate the void with echoes of ourselves. And perhaps that's the real discovery here, not what Mars is showing us, but what it's revealing about us, the curious creatures staring back at its rocks, seeing statues in the shadows. Even in the barren landscapes of Mars, the human mind insists on finding the fantastical, like the day Curiosity rover captured what looked like a mermaid lounging on the rocks. The so-called Mars mermaid appeared as a sinuous, undulating silhouette with a tapered tail curling gracefully against the dust and a rounded head tilted upward, as if gazing at the pale pink sky. The image spread like wildfire, with some joking about Martian folklore and others half-seriously questioning if we'd stumbled upon some cosmic siren. But as with so many of Mars' illusions, this one unravels under scrutiny, revealing a story not of myth, but of light, shadow, and the relentless creativity of erosion. The mermaid's enchanting form is the result of two key factors: perspective and the sun's low angle. When Curiosity snapped the photo, the rover was positioned so that a wind-sculpted ridge of rock caught the light along its crest while leaving the underside in deep shadow. This contrast exaggerated the rock's curves, transforming what might otherwise look like a simple outcrop into something fluid and organic. The tail is likely a hardened lava vein or mineral deposit that resisted erosion while softer rock around it wore away, leaving behind a twisting, raised spine. As for the head, it's probably a boulder that broke free from the cliff above, coming to rest at just the right spot to complete the illusion. What makes this mirage so compelling is how it plays with scale. The mermaid is actually quite small, no larger than a household pet, but the rover's close-up lens and the terrain's emptiness make it seem more prominent. On Earth, we're used to seeing objects in context, trees, buildings, or other reference points that ground our perception. On Mars, where the landscape is a monochrome sea of dust and rock, even modest formations can take on outsized significance. A pebble becomes a monument, a shadow becomes a silhouette. The science behind this phenomenon is just as fascinating as the illusion itself. Mars' thin atmosphere scatters light differently than Earth's, creating sharper contrasts between sunlit and shadowed areas. At certain times of day, especially during the golden hour when the sun hangs low, these effects intensify, turning ordinary geology into a gallery of pareidolia. The same forces that carved the mermaid also sculpt the planet's other uncanny shapes: the floating spoons, the skulls, the statues. It's a reminder that Mars isn't just a planet, it's a stage where sunlight and geology collaborate in an endless performance of shadows. Yet the mermaid's legacy isn't just about optics, it speaks to why we explore in the first place. Mars tantalizes us because it's almost familiar, a world of deserts and mountains, of frost and wind, but twisted just enough to feel alien. When we project our myths onto its rocks, we're not just seeing mermaids, we're seeing ourselves, our stories, our longing to bridge the gap between the known and the unknown. And who knows, maybe one day when humans finally walk those dusty plains, they'll pause at this very rock, smile at the coincidence, and call it Mermaid Ridge, not because it's real, but because the universe has a way of meeting us halfway, turning cold geology into shared wonder. Of all the illusions Mars has conjured, few have captured the public imagination like the infamous Mars UFO, a perfect, saucer-shaped shadow gliding across the terrain in orbiter images. When NASA Mars Reconnaissance Orbiter first captured this eerie formation in 2016, the dark, disc-like silhouette appeared so crisp against the sun-baked plains, it seemed to defy natural explanation. There it was, a classic flying saucer outline, complete with a domed center and tapered edges, as if parked on the surface or hovering just above it. Internet forums erupted with theories of cloaked alien spacecraft, secret government missions, or even evidence of a Martian Air Force. But like so many of the Red Planet's mysteries, the truth lies in the intricate dance of light, shadow, and geology. This otherworldly shadow isn't evidence of extraterrestrial visitors, it's the ghostly imprint of a perfectly ordinary crater. The UFO shape emerges when sunlight strikes the rim of a shallow impact basin at a low angle, casting a circular shadow that's distorted by the crater's gently sloping walls. The domed appearance comes from the central uplift found in many craters, where the ground rebounds after a meteorite strike, creating a small peak in the middle. When the sun sits just above the horizon, this topography paints a shadow so geometrically precise it looks manufactured. From space, the effect is uncanny, a pitch-black disk that seems to float, its edges razor-sharp against the surrounding terrain. What makes this illusion so convincing is the stark simplicity of the shape. Our brains are wired to recognize patterns, and few silhouettes are as culturally loaded as the classic flying saucer. The shadow's symmetry feels intentional, engineered, not the product of random cosmic collisions. Adding to the mystique is the shadow's size, roughly 150 feet across, large enough to match popular depictions of scout ships in sci-fi lore. Yet high-resolution images reveal the truth in exquisite detail. Zoom in, and the UFO dissolves into the rugged texture of the crater's rim, its edges fraying into boulders and dust. The magic lies in the distance. From orbit, the imperfections blur into something unnervingly perfect. Scientists love this formation not for its alien allure, but for what it teaches us about interpreting planetary landscapes. Shadows are deceptive storytellers. On Earth, we're accustomed to how light interacts with familiar shapes, trees, buildings, mountains, but Mars follows different rules. Its thin atmosphere scatters light differently, intensifying contrasts. Its lack of vegetation or human-made structures removes visual anchors, leaving us adrift in a sea of ambiguous forms. A shadow that would look unremarkable in a desert on Earth becomes a Rorschach test on Mars, where every anomaly feels like a clue. The real irony: craters like this one might actually hold clues to extraterrestrial life, just not the kind the UFO theorists imagine. Impact basins often expose subsurface minerals or ice, making them prime targets for astrobiology research. Some craters even act as natural traps for organic material, preserving it in their sheltered bowls. So while this particular saucer-shaped shadow isn't a spacecraft, the ground it darkens could one day yield discoveries just as groundbreaking. In the end, the Mars UFO is a testament to the planet's talent for theatricality. It doesn't need alien engineers to create wonders, just sunlight, time, and a little cosmic serendipity. And perhaps that's the most humbling lesson of all. The universe doesn't need to hide flying saucers to amaze us. Sometimes all it takes is the right shadow in the right place, and a world millions of miles away becomes a canvas for our wildest dreams. There's something haunting about a blur, especially when it's captured on another world. In 2019, as NASA Curiosity rover panned its cameras across the rocky slopes of Mount Sharp, eagle-eyed viewers spotted something strange lurking at the edge of the frame. A tall, shadowy figure standing motionless in the distance. With its hunched posture and rough, almost shaggy outline, the shape quickly earned the nickname Mars Bigfoot. Social media lit up with theories. Was this a lone survivor of some lost civilization? A trickster alien playing hide and seek with the rover? The resemblance to Earth's mythical Sasquatch was uncanny, but as with so many Martian mysteries, the truth is tangled in pixels and perception. What makes the Mars Bigfoot so compelling isn't just its shape, it's the ambiguity. The figure appears in a low-resolution portion of the panorama, where compression artifacts and distance turn ordinary rocks into smudged, suggestive forms. Without crisp details, our brains fill in the gaps, constructing familiar shapes from chaos. This psychological phenomenon, called pareidolia, is the same reason we see faces in clouds or animals in passing cars. On Mars, where every landscape feels alien, the effect is amplified. A jagged boulder becomes a crouching figure, a wind-scoured ridge transforms into a towering silhouette. The Bigfoot illusion is a perfect storm of distance, lighting, and the human mind's hunger for patterns. But the real story here isn't about a phantom creature. It's about the limitations of interplanetary photography. Curiosity's cameras are engineering marvels, but they're not immune to the harsh realities of Mars. Dust scatters light unpredictably, and the planet's thin atmosphere creates high-contrast shadows that exaggerate textures. When you combine these factors with image compression necessary to transmit data across millions of miles, details soften, edges blur, and the ordinary starts to look extraordinary. The Bigfoot is likely just a rock formation, its hunched appearance the result of a boulder perched atop a narrow pedestal, with shadows stretching its profile into something eerily bipedal. What's fascinating is how these blurry anomalies persist in public imagination despite countless debunkings. The Mars Bigfoot joins a long lineage of low-resolution legends, from the infamous face on Mars to the Martian Yeti spotted in earlier Rover missions. Each time, higher-quality images or alternative angles reveal mundane explanations, yet the cycle repeats. This isn't just about gullibility, it's about the stories we tell ourselves to make the unknown feel closer, more relatable. A Bigfoot on Mars, no matter how improbable, bridges the gap between our world and the void, turning cold geology into something alive with possibility. The Bigfoot illusion also underscores a deeper challenge in space exploration, the tension between scientific rigor and public engagement. Scientists see raw data passed for geological clues. The public sees a canvas for myth. Neither perspective is wrong, but they highlight how differently we process the unfamiliar. Future missions might mitigate this with higher resolution cameras or even AI tools that flag potential pareidolia in real time. But until then, Mars will keep serving up these Rorschach-test shadowy figures and spectral shapes that say as much about us as they do about the rocks they really are. So while the Mars Bigfoot isn't proof of extraterrestrial life, it's a testament to the power of a single pixel to ignite curiosity. In the end, the most enduring mysteries aren't always out there in the dust, they're in the way we choose to see them, blurry edges and all. High above the Martian surface, orbiting cameras once locked onto something that seemed to defy the randomness of nature, a towering, rectangular slab of rock jutting from the dust like some ancient obelisk. This Mars monolith, as it was swiftly dubbed, stood starkly upright amidst the rolling dunes of Phlegramontes, its sharp angles and flat faces appearing almost machined against the soft curves of the surrounding landscape. Measuring roughly 16 feet tall and 5 feet wide, dimensions that only amplified its uncanny symmetry, the formation looked less like a product of natural erosion and more like something deliberately placed, a cosmic calling card left for future explorers. The monolith's discovery in 2010 sparked immediate comparisons to Earth's own iconic stone sentinels, Uluru's sheer faces, the towering basalt columns of Giant's Causeway, or the solitary grandeur of Devil's Tower. But the resemblance that truly set imaginations alight was its eerie echo of sci-fi lore. Arthur C. Clarke's 2001, A Space Odyssey had etched the idea of alien monoliths into popular culture, and here was a real-life counterpart, standing sentinel on a world humanity had yet to touch. The parallels were irresistible. Was this a nod from the universe, a cosmic inside joke, or something more? Geologists, of course, had a less theatrical explanation. The monolith is likely a fractured remnant of a larger rock face, sheared off by eons of thermal stress and wind erosion. Mars' wild temperature swings, sweltering in daylight, frigid at night, cause rocks to expand and contract until they split along natural fault lines. The planet's weaker gravity, just 38% of Earth's, might have helped the slab remain upright longer than it could elsewhere, while relentless winds sandblasted its surfaces into those unnervingly flat plains. What we're seeing isn't artistry, but the patient work of physics, a masterpiece of entropy. Yet the monolith's cultural weight can't be dismissed. It exists at the intersection of science and myth, a Rorschach test for our cosmic curiosity. To some, it's a testament to nature's ability to mimic the artificial, proof that the universe needs no architects to create the uncanny. To others, it's a beacon, a reminder that Mars still holds wonders we can't yet explain. And for a handful of hopeful speculators, it's a relic, a marker left behind by some long-vanished civilization, waiting to be decoded. The truth, as always, lies in the details. High-resolution images reveal the monolith's surface isn't perfectly smooth. It's pocked with microfractures and veined with mineral deposits, betraying its geologic origins. Spectral analysis suggests it's basalt, a volcanic rock common on Mars, its iron-rich composition giving it a darker hue than the surrounding dust. Crucially, there's no vanishingly thin edges or impossible precision. The perfect rectangles are an illusion of distance and lighting, much like Earth's own natural monoliths appear more sculpted from afar than up close. What makes this formation endure in public memory isn't its mystery, but its metaphor. The monolith embodies humanity's push-pull relationship with Mars, a world close enough to feel familiar, yet alien enough to keep us guessing. It's a mirror for our ambitions, our fears, and our relentless need to find meaning in the void. Whether a trick of erosion or a whisper from the cosmos, one thing's certain. When humans finally crest those rust-colored dunes and stand before this solitary sentinel, they'll be confronting not just a rock, but a legend, one that's been waiting patiently in the silence for its audience to arrive. From floating spoons to fossilized wood, from ghostly jellyfish streaks to pyramid-shaped rocks, Mars has proven itself the ultimate illusionist, a world where every crater and dust devil seems to hold a riddle. Over 30 strange discoveries, we've seen how wind and water, shadow and science conspire to create the uncanny on a planet that's equal parts museum and mirage. The vast majority of these Martian enigmas have been decoded, like the face revealed as a trick of light or the traffic light exposed as a camera flare. Yet even as explanations emerge, there's an undeniable thrill in the gaps, the phenomena that still nudge at the edges of our understanding, like those mysterious seasonal methane spikes or the bizarre underground caverns that might hide secrets no rover can yet reach. What makes Mars special isn't just its geology, it's the way it mirrors our own restless curiosity. Every strange rock is a prompt, a challenge to look closer and ask how. Why, what if? The best science isn't about shutting down wonder with cold facts, it's about using those facts to dig deeper, to appreciate how much wilder reality often is than fiction. Because let's be honest, a wind-carved spoon that looks like it's defying gravity is cooler than any alien artifact we could invent. Nature, it turns out, is the ultimate artist. So as we wrap up this cosmic tour, here's the real takeaway. Mars isn't done surprising us. New missions like the Mars Sample Return Project or Elon Musk's dream of a human colony will rewrite what we know all over again. Maybe one day we'll crack the planet's biggest mysteries, or maybe, just maybe, we'll find something so strange it defies explanation entirely. Until then, keep looking up, questioning, and marveling. If you've loved this journey through Martian oddities, don't forget to hit subscribe. We've got plenty more space secrets to explore, from the icy geysers of Enceladus to the raging storms of Jupiter. And drop a comment below. Which of these 30 discoveries blew your mind the most? Was it the dragon scales, the floating spoons, or something we didn't even cover? The universe is weird, wonderful, and waiting, so let's keep exploring.